So today we can go with the Kubernetes, right?
I think you already started the Kubernetes.
Oh, okay. Kubernetes starter, right?
Yes, we did.
That that theory part or practical or both?
Theoretical part. No, we didn't go into practical set. I think we are done with theoretical part.
Okay, okay. So today we can set up a Kubernetes cluster. Okay, managed Kubernetes cluster, manager cluster. So what are the prerequisites we need to ensure when we are going to set up a managed Kubernetes cluster? Any idea?
I think Docker should be installed.
Mm, no need of Docker actually. For managed Kubernetes by default,
Okay,
uh,
managed one. Okay, cloud services are managing it. Okay, I think. Mm,
yeah, it's managed by cloud services, but it's not using the Docker service actually for container creation or container management. So coming to Kubernetes, the container service is container D,
identity.
similar like Docker. Okay, so this is the container service works within Kubernetes cluster to create containers, manage container like that. Before content Docker is running actually by default, but Docker is not sufficient. So that's why now the content is working inside Kubernetes.
Okay.
So setting a Kubernetes, we can do two, three ways. Okay, first way we can go manually, go through the console, AWS console. Second thing is automation. Automation using different tools. Okay, today we will automate the entire Kubernetes bootstrapping using EKS ETL tool. It's a tool actually to set up in Kubernetes quick way. Okay, within a single command we can set up the Kubernetes, and also using a single command we can store in the Kubernetes also.
So for managed service, do we need to install container deep? Uh,
Yeah,
is there anything else other than container D? Is it only a
Docker,
container?
Docker, 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 Docker. The thing is, we need to ensure one of the service is installed for managing container. I mean, creating container within Kubernetes. So we called as container runtime, okay, within Kubernetes. So any container runtime we can use. So by default, container D is using for the container runtime.
Do we have any other container
Docker.
runtimes? Other, or only Docker? Okay. Docker and container D.
Yes, one more there. That is, I missed the name actually.
So why can't we use Docker instead of container D? Does it have any disadvantages?
Right.
So what is the advantage of container D over like Docker?
Uh, Container D is most, when comparing with the Docker, so uh, advanced container service actually in comparing with the Docker. That's why manager Kubernetes are using container D by default.
Also, Kubernetes and Docker solve different problems, right? They are built for
Yes.
different things. So, container D is a command from Kubernetes.
Container D compared with the Docker, it's a lightweight actually. Okay. Also, simpler than Docker and provide better performance. That's why container D. Other than Docker and container D, there is another container runtime that is CRIO. CRIO. This also is a lightweight, especially for Kubernetes. Okay, lightweight container runtime, and this can implement container runtime interface natively within Kubernetes. Also, directly works with the Open Container Initiative, that is OCI. Docker actually used before the version Kubernetes version 1.20. Okay, before 1.20, the container runtime running on Kubernetes is Docker actually. Now the latest version of Kubernetes is 1.31 or 2, I think. 3.31 or 2, like.
So these will be same for every cloud service, right?
Right. Docker is not a lightweight actually. Docker is deprecated, okay. Coming to Kubernetes, Docker is deprecated. Uh, Docker also is a not lightweight version actually. So that's why it's deprecated. Actually, it has extra component, okay. Coming to Docker, it has extra components. That's why it's not a lightweight service.
Was Docker created before Kubernetes?
Sorry?
Was Docker created before Kubernetes?
When coming to Kubernetes cluster, here in worker node, okay. Nodes are there, right? So inside node, the Kubernetes will automatically create container, right? So for that, we need to define some container service within the Kubernetes to perform this. So before 1.2, Kubernetes version 1.2, the Docker service is used for that. Nowadays, or after the version 1.2, now by default, the container service is container D. It's lightweight version of container service.
So if Docker is deprecated, so whomever is using Docker, they have to upgrade to container D. Is it like doable stuff, or it is hard to upgrade to Docker D when compared to Docker? Sorry, container D when compared to Docker.
These are all the things managed by the cloud provider actually, which container service. Everything is managed by cloud provider. We don't bother
Okay.
about that.
Okay.
So we are going to create cluster, okay? We can do two, three way. Like one is we can go to the search bar and type EKS. And the second way, type EKS. So we will landing to the EKS cluster service dashboard. Okay. So the next thing is we need to automate. For automating, we need a machine. This will be a local machine, a local laptop or any machine, or else we can take a one EC2 machine. Okay. Leveraging on EC2 machine. So in this case, I will take one EC2 machine and perform everything from that machine. So I call that machine is my local machine as well. Okay. So I will create a EC2 machine to perform that. And from the EC2 machine, EC2 machine is one of the service here, right? In AWS, this is a service actually. So using the same service EC2, we are going to create another service that is EKS. For this scenario, we need to do one more thing, that is we need to create a role and attaching some permissions, okay, policies and permission to that role. Finally, we will attach that role to the EC2 machine to perform this activity. The role is nothing actually. The role is for managing EKS cluster within the same AWS account and give some administrator access and EKS service. Some permissions are there, EKS for managing EKS or for creating EKS. So that's all the roles that, that all the permission that we attach to the role actually first. Then we will attaching that role to the EC2 mission. So the mission got all the permission to do the activity.
So we are creating only one node now.
One node, right?
Uh-huh.
No. First, we need to set up a machine to create EKS. Directly, we can go to here, Akhil, like EKS, type EKS, Elastic Kubernetes Service, click on. And this is a dashboard. We can go through the dashboard to configure Kubernetes, or we can set up the same thing via automation. Okay, so here we can click on create, then we need to go through the step-by-step process. So it's a lot of stacks we need to follow up whenever we go through the manual way. So we can automate the same. So we need to leverage a EC2 machine to do the activity. That's all. I'm launch my machine. Also, we will manage the Kubernetes from this machine. Okay. T2 micro is fine because this is just a machine to like a bridge to connect our Kubernetes cluster. We need to do some prerequisite. Okay, if we installing Kubernetes, we need to do some prerequisites. I mean, some dependency we need to install in our machine. So this is the EC2 machine, right, that we created now. This is EC2. So first we need to install some tools here. Okay, so I told you like we are going to configure this EC2 machine via automation, right? So we using EKSCTL tool. So we need to install the EKSCTL tool inside the EC2 machine. Then we need to install the native kubectl command also. Kubectl. This is a native command line tool to interact with our Kubernetes cluster. As of now, we didn't create the Kubernetes cluster, but after installation of the Kubernetes cluster, we need to manage Kubernetes cluster, right? I mean, managing, administering application deployment, everything we run by kubectl command. Also, we need to learn some kubectl command as well. So these two things we need to install this machine or which machine that we are managing the Kubernetes. Okay, this will be in the local machine as well, laptop or anywhere we can install both.
Can we automate the creation of EC2 machine too?
Yes, that's I will include in the Terraform class. Create, configure or launching EC2 machine and everything like creation of VPC, subnet, routable. Okay, so the first thing is we need to install EKCTL. So for EKCTL installation, we have to run some command. Okay, so this is a command. So this is nothing. It's we download the data from the package from this is a directory. Okay, so this is for the EKCTL. So it will pull the package and also it will uh, unzip the package. Then we can see the package in this directory temp ekctl. So using sudo mv, we need to move that from user bin user local bin directory. Okay, so we can see the ekctl under the directory. So hit enter. So everything is done. You can see the version as well. See, so we download. Pull the package. Okay, for the ekctl. Now we can run ekctl from this machine. So the next thing is we need to install kubectl same way.
Is there a documentation related to this?
Yeah, I will share that. So this is the same curl command. So it will pull that kubectl package from this directory. Also, for the specific executable file of kubectl, we make it as executable permission. Okay, that is chmod plus x. So that's fine. Now we can directly configure, installing kubectl within a single command using ekctl command line tool. So this is a command to create a cluster. Okay. It will starting from ekctl. ekctl we already installed. Okay, so using the ekctl command line tool, we are going to create a Kubernetes cluster.
See you. All right, then. Let's go ahead.
Hey Amol, can you mute yourself?
Yeah, I mute. Okay. So using ekctl, we are now talking to ekctl. Okay, ekctl create cluster. So that's our first command. ekctl create cluster. Then we need to define the name dash name. Then here you can see the name of the cluster. Okay, I will change the name of the cluster. So currently the name of the cluster is just TKS. Now I'm changing to GSNU. Okay, so that will be the name of the cluster. Then we need to define the region where we are going to configure this GSNU cluster. That we need to define here -d region. Then define the region US East 1. That's my default region. That's fine. Then we need to define the node group name. So that's came -- node group -name. After that, we need to define the node group name. Here I have defined my node. Okay, that's fine. Node group means Okay, for example, we deploy one cluster. Okay, assume that like that. So the cluster have two. Okay, so these two node contain in a group actually. Coming to Kubernetes. Okay, this is a worker part and this is a master, and this will be the worker. So for this group, we need to give some name, that is this name actually, my node. Then we need to define dash dash node type. Okay, node type means this is easy to mission configuration. So we can define T2 small, T2 micro, T2 large. As per the requirement, we can define any configuration. Then dash dash managed. This means these nodes, right? These are node 1 and node 2. That is EC2 and EC2. So these two EC2 mission managed by cloud provider. That is defining like this. Managing in the sense of patching activities, updating package activities, a lot of things that the AWS will automatically do. You don't bother about anything, even the security patching as well. Then dash dash node. How many node we need to set up for our cluster? So here you can see it's defined as 2. We can set up 3, 4 like that as per the requirement. So this is a single command to create everything. Got it.
In a worker pod, we have 2 nodes now.
Yes, I'm changing to 3. Okay. So we got 3 worker node with a Kubernetes cluster, hit enter. So it will start to create. One more thing we need to do. This is related to the permission actually, because I told you this is one service and we are going to create another service using EKCT. So for that we need to create a role. In my case, I create a role. Okay, so I'm going to attach, select the mission, go to security, modify role. So here we have, see, this is my role that I created earlier. Okay, so EKS admin. So I am selecting that one and update IAM. I'm audible, right?
Yes, you are.
Okay, fine. Okay, this is a dashboard, IAM dashboard. Okay, here actually we creating users, groups, uh, roles, policies, everything related to the AWS account. For example, uh, any one of you join in a company. Okay, so that company using AWS account, then they will create a user for you to accessing the AWS account. So for that, they will the administrator or the corresponding person go to the root users and create user, then give your name and create a user and password, permission, everything, and share with you. So you can log into the AWS console. So that's all the parts related to the IAM. Okay. So in this case, we will creating a role actually. So that role we can first we need to create the role and we need to assign the role to the corresponding scenario. So create a role. So here we can see a lot of entity type here. Okay, trusted entity. So in this case, that this is related to AWS service. So select that, and we need to define the use case as well. So the use case in this case EC2, because we are going to do, I mean, we are going to create some roles for EC2 mission, right? So select EC2. Next. Here actually the permissions, okay, page. So we need to add some permission for that role, okay, the role we are going to create. So in my case, I think I added administrator access. then eCase. This is the main thing, okay? Type eCase and select the Amazon eCase CNA policy. Select this one and Amazon eCase cluster policy. These two is fine. Now, next and create the policy. That's all. Name something and got it. Any doubt? I will show you once again. Okay, the policy. I mean, policies that I used for that role, eCase admin. This is the role I used. Okay, so here you can see three policies are attached: administrator access, Amazon eCase cluster policies, and Amazon eCase worker node policies. Okay, worker node policies used. Okay, not that CLI policy, eCase CLI. So these two are fine. eCase cluster policy and Amazon eCase worker node policy. Got it. Any doubt?
I think there is a lag in the screen actually.
Give me a second. It's fine, right?
No, yeah.
Okay. Now we're creating the cluster using the automation way using EKSQL tool. This is not a native EKS tool. Okay, this is developed by some other open source team, and we just leveraging the tool. Okay, to bootstrapping the cluster. So now we are creating a cluster, right? A Kubernetes cluster with the master part and worker part with a three node: node 1, node 2, and node 3. Here some components are there for the master, like API, etcd, controller,
Scheduler.
scheduler. So these all the parts managed by AWS, right? So we don't bother about that. AWS, that's why we called as manager one. So actually these are running in a pod, okay, in a container actually. Each service is running in a container within the Kubernetes, but we don't bother about that. Container means first there is a pod there. Inside the pod, there is a container with the corresponding services like that. Okay. Also, we can see three node here: node 1, node 2, and node 3. Then these all the things. Also, some components related to node as well, like kubelet, kubeproxy, and container runtime. Each machine: kubelet, kubeproxy, container runtime, like that. Okay. So the next thing is we need to deploy some application, right? So for that, we need to write YAML file, like deployment or application for that YAML or any name you can use. And that extension look like .yaml, okay? That's the format. And using the YAML format, we need to write the YAML configuration. We called as the YAML manifest, okay? YAML manifest. So the manifest means it's including everything related to the application. Like it's starting with the API version, then kind, then metadata, And related to the application details, we need to define here. The main part in this YAML manifest is coming to the container specification. Okay, container specification. We need to define the container name, and main thing is container image we define here, which application image that we are going to create using Kubernetes. So write all the YAML file. We can directly apply the YAML file to the API server using kubectl command. Kubectl apply, define the file -f, then we need to define the file name. That is deployment.yaml. Deployment.yaml. So hit enter. So it will push from this local machine, okay, where we are managing the Kubernetes. Okay, so in this case, that's easy. It's a easy to mission, right? So in the easy to mission, we need to create the file, and using kubectl apply, we need to apply the file from the ECD to the cluster. So the API server will. This is actually when we type in kubectl apply. This is a API call actually. Okay, API call. So API call hitting to the API server, taking API server will taking that request and go through the components, and finally the scheduler will schedule the applications to the worker node. Got it. Also here we need to define the replicas. Okay, I missed the replica. Replicas means how many instances for our application. Okay, for example, replica is one. That means it will create a pod with a container. Inside the container, the application running. Replicas two. That means it will create two pod with like pod one, pod two. Inside container we can see container one and container two. The application app. These all same application. Okay. So if the replicas three, it will create similar like three pod. So coming to the EC2 mission, the scheduler will schedule the first pod to the first node like that. Second pod goes to the second node. Sorry, second pod goes to the second node. Third one goes to one or two or three. That's all managed by the scheduler actually. I mean, scheduler will looking for the best node. Okay, the best node means each node have CPU, memory, everything, right? CPU memory. So scheduler will choosing the best node actually. I mean the best node in the sense of node health, node affinity. So a lot of the things the scheduler will looking, and it will choose the corresponding node and deploy the application. So the pod will create here, and the container also create container here, and the application will expose. So if any pod is having any issue, no, don't worry about the application, because the application is belongs to another node as well. Got it. See, we can see first is creating the cluster. Now the second part is creating the node group and node configuration and everything. So here actually it will set up in the EC2 mission, and it that EC2 missions join to the master part and everything in background actually. Okay, the cluster is up and running. See here, EKS cluster, GS no, in US East 1 ready, region is ready. So here we can see one error that is related to IAM authenticator, okay. AWS IAM authenticator. So we need to install one more service that is AWS CLI, AWS configure. So here it is not installed, so we need to run this one. Copy paste. That's one of the prerequisite, okay.
What is this AWS CLI used for? But EKS CTL is used for like interacting with the cluster. So
Yes,
how about
AWS CLI is AWS native command line tool, AWS CLI. So using AWS CLI, we can interact with the AWS account, okay. For example, we have a laptop here, okay. So inside the lap, yeah, we need to install AWS CLI inside the laptop. We can manage AWS account via command line.
Oh, okay.
So don't need to log into the AWS account. For example, if we
Okay.
need to set up a like EC2 mission, we can done through AWS CLI.
Mm.
So one more command we need to run, that is AWS update kubeconfig. Okay, this is actually nothing. For example, if we install a Kubernetes service, said that Kubernetes have a kubeconfig file. That file, kubeconfig file means it's a that file contain the entire Kubernetes information. Okay, so how we can authenticate using Kubernetes, sorry, kubeconfig file. Yes, app, right? So, okay, see here, added new context, and we can see here that context as well under the root directory. So copy cat. We can see the file as well. This is a kubeconfig file. This is a Kubernetes file that we are using for authenticating Kubernetes. Okay. For example, if we need to integrate the Kubernetes cluster with any of the CI/CD tool. Okay, like for example, Jenkins. So we need to copy the entire configuration file from the API to that command AWS. This is the entire file. Okay, so this file we use it for the CI/CD part as well to communicate with the Kubernetes. So in this case, this config file in our local machine, that is a EC2 machine. So we can directly communicate with the Kubernetes using kubectl command. Now we are good to run kubectl commands. Okay, so this is actually API code. Okay, we are trying to checking the Kubernetes details using kubectl command. Also, we can deploy application using kubectl command. So for example, first we need to know how many nodes are running there. So using kubectl get, this is a good get query, okay? Get node. See, 3 nodes are running there. Node 1, node 2, node 3. Three EC2 missions actually. And the Kubernetes version also here we can see 1.309. EKS. We can go to the dashboard manually. Also, we can see the cluster. See, the cluster is here. Yes, no active and upgrade. There's no version there. I think that's why it's up. See like this. and everything we can see here. We can log into upgrade insight. So this will be seen that mission, I mean Kubernetes cluster detail within AWS account via UI. Now this is actually using kubectl, okay, kubectl command. So most probably 100% or 95% we managing Kubernetes cluster using kubectl command, 99%, okay. Now similar way we need to run after installing Kubernetes, we using kubectl command to getting all the things, okay. So now we read that how many nodes are running in our cluster. That is 3. It listed as 3. Now we need to check how many pods are running. So we need to run kubectl get pod. So it will show the pods. Okay. Now you can see here no resources found in the default namespace. Coming to Kubernetes, the namespace is one of the topic actually. So namespace. Okay. What is namespace means? It's a logical group. We can call it as a logical group or logical environment within the Kubernetes cluster. Okay, so we need to create a namespace first. So by default, coming to Kubernetes, if we install Kubernetes, we can see a default namespace. Default namespace. All the application will go through, deployed in this default namespace. Okay, if we create anything or if we did not define anything. So why we using namespace? For example, we have multiple clients, okay, and ABC, Mango, like that. We have 2 clients, okay. So if we deploy their application directly, all the application belongs to default namespace. That is not a good practice actually. We need to sort out each client's applications within a small group. That's why we're creating namespace. It's an isolation actually. So first we need to create a namespace like ABC. Then we need to deploy the ABC application to the corresponding namespace. So it's easy to checking the application and pod and everything within the namespace as well. Also, multiple teams can work with the different namespace. That's another benefit. So here you can see the namespace also we can see using kubectl command, kubectl get namespace, short form NS. So it will show the default namespace, kube node lease, kube proxy, kube system. These are the namespace related to the master part. Okay. So I told you like master commands are also running in a Kubernetes, right? Kubernetes pod and container. So the kube system, you can see the kube system is the main namespace that belongs to kube master components. Okay. kubectl get pod. I will check that port, how many ports are running in the specific namespace, okay? Dash n. So we need to define the namespace. Otherwise, it will looking for the default namespace as well. So that's why above you can see no resource found in the default namespace. So kube proxy, kube system. See, these are the nodes that for the master components actually. Kube proxy, core DNS, AWS, kube public. No resource found in that 2 namespace, only in the kube system. Okay. So if we need to create a namespace, we need to use kubectl command. Kubectl create namespace, short form NS, then the namespace name like gsnew. So it will create a namespace. See, kubectl get NS. So here you can see the namespace we created. Now, if we going to create any application, we can define the namespace as well, gsnew. So the application belongs to the corresponding namespace. Got it? So now we can deploy some sample application, okay, using a YAML file. I will check for some sample application. Okay, I told you we need to keep the YAML file right in our local machine. So we need to create a YAML file using nano tool deployment.yaml. So it will create a file and I will show you one of the sample application. So yeah, so here you can see this is a facing some internet issue. Okay, that's why automatically. Now my screen is visible, right, all of you?
Yes.
Yes.
Okay, I'm just copying some sample application YAML file. So here you can see API version is starting with the API. All the YAML file will starting with the API version. Okay, API version means the API version that we have used in our Kubernetes cluster. Okay, so coming to API version, it's classified into two types. Okay, one is core name, core group, and named group. Named group. So coming to the core part, okay, core group or core part, some versions are there that is beta v1, beta v1. So that's the previous version. Now we use v1 version actually. That is a stable version v1. So we can define API version v1. That's stable version of our Kubernetes API. Also named groups are there. Okay, named groups means before the v1 we define some names. Here you can see app. So we define a name, right? So that is a named version, apps v1. Got it. Some other example, like for example, we using some auto scaling, something like that in Kubernetes. So we need to define the corresponding name before the v1. So that is named group. So that's fine. Now coming to the kind. So we need to define the kinds in Kubernetes. Okay, kinds means under the parameter kind, we need to define the resources in Kubernetes. Some resources are there. deployment is one of the resources. So what is deployment? Deployment means it's a, if we define the kind as deployment, that means within that application YAML manifest, we define the application replica set. So here you can see the replica, that is 2. And that this deployment will managing, looking, this is like a manager. Okay, deployment, you can see it's a like a manager, and the deployment will ensure all the application instance, that replicas will running inside the Kubernetes and everything. So that's why we use the deployment here. And after that, we need to define the metadata and name for the app deployment. So this will be the name for this deployment, Mario deployment. Any name we can define here. Then we can see the specification we need to define below the name. So first thing is replicas. That means how many instance for, how many identical port for our application. Okay, that is 2. If we define 4, it will create 3 port like that. Now it's creating 2 port, and inside 2 port we can see 2 container. Also the application running here. Then the match label. So under the selector, then we can see the match label, and we define the application name. This is actually the application name, Mario. Also template, we define the label, same match labels. These 2 things are same, okay? Same name we need to define both sides. Then again, the specification for the container part. This is a container part specification. So here we need to define the container name. This is a container name. Any name we can give it here. And the image name. This is an image name for our application. This image will be available in Docker Hub. Actually, this file looking for the Docker Hub username and image name like this. If the image is not there, this application not running. Actually, we will face some error. Then the port we need to define. Coming to container part, we need to define the port as well, container port. So the container port is 80. So this will deploy a deployment, and the name is Mario, and it will contain 2 application instances. The name, application name. Also, it will take the image from the official, not official actually. This is a public image from Docker Hub. Got it? So we can save the file and execute. Control X by tender ls. See, the file is here. So using kubectl command, we can deploy the file. Okay. So it will create, we called, coming to Kubernetes is a container orchestrator. It will automatically deploy or automate the deployment process, right? So now you can see whenever we type in kubectl, apply the file name. So the Kubernetes will take the file actually. After hit enter via the API. Okay, the API server will take the application file, and it will automate the application deployment. Got it? Only we need to define the everything in the YAML file. The rest of thing will handled by the Kubernetes. That's why we called as Kubernetes will automate application deployment. Apply -f. This is for the file name flag. Okay, so we need to define the file name. For example, if we have multiple files here, we need to use the corresponding file. Hit enter. See, it created the deployment actually. So we can see kubectl get pod. Application is deployed. Got it. This is a 2 pod actually, pod 1 and pod 2. So inside the pod 1, you can see ready 1 by 1. That means the container 1 is up and running. If this is 0 by 1, that means the container is not running, having some issues. Also, you can see the status is running. We created a YAML file, right? Sorry, a namespace, but this is not be pointing to the corresponding namespace. If we need to assigning the application to corresponding namespace, we need to define this command as well, -name. This is for the namespace definition, and we need to define the new created namespace like gs new. So it will go to the namespace that we created. Got it? Now the application is deployed, right? So for example, we can see that application that here you can see two pod there. Okay, we have two pod running. We have three pod node, right? So we can check the pod is belongs to which node as well. kubectl get pod hash or wide. See, so this is a first pod, and we can see the first pod belongs to which node. This is a node name or node IP. So the first port belongs to the node that ending with the 196 private IP. Okay. The second node you can see it's another node that ending with the 32 private IP. Good. So this way the Kubernetes will assigning port to different node. So here three node there, three node. Okay. And this pod belongs to one of the node, and the container running inside there. And the second pod goes to second node. Pod goes to second node, and you can see the application container here. So the application is deployed inside the container, right? Only inside the container. Sorry, inside the cluster. Okay. This is the entire cluster, the master part and the worker part. Now we need to expose the application, right? How we will expose the application? Because we need to access the application, right? Application is running fine. So how will access the application via browser or like that? Anyone?
App proxy.
Proxy means
We're gonna expose that IP.
yeah. Actually, for this scenario, okay, we need to create a service for the specific application. Okay, so service. So actually service.yaml, we need to create a separate file actually, service.yaml, and we need to apply the file service YAML. So it will create a service within Kubernetes cluster, and this is a service. And inside the service YAML, we need to define the corresponding application. So I mean, for which application we are going to create a service. So everything we define inside the YAML file. And the service knows that is for the specific application. So the service is connected to the corresponding port. Not connecting actually, it will routing the request to the corresponding port. So using the service, we can define service type. Different types are there, right? Cluster IP, node port, load balancer. So as per the requirement, we need to define the type. So in this case, I will assigning load balancer for this application. So the Kubernetes will automatically create a load balancer for us to accessing the application. Also, we can use the load balancer DNS to access the application. So using cluster IP, it will only accessible inside the cluster only. For node port, also it's exposing the application, but it's not for production environment. So using node port, we need to use the node IP with some port number, okay, some static port number to access the application. So that I will show you in managed Kubernetes, sorry, self-hosted Kubernetes, okay, how we will set up a service type as a node port. So now we need to write that YAML file for creating the service. So the application will expose via the service. Okay. So before that, we can check the service as well. Kubernetes get SVC, short form of service. So here you can see there is a default Kubernetes service. Okay. This is a default one for the Kubernetes, and you can see the cluster IP actually there. Cluster IP means internal communication only, and this is a private IP for the Kubernetes. So it's private. This is actually a private network. Okay. That's all. So now we are going to create another file, nano service.yaml. So this is a service.yaml. Okay. Here also we need to define the API version. So API, and here the version is v1. Okay, the core stable legacy version. This is a legacy version we call this. And the kind in this case, the kind service is another resource, okay, for the Kubernetes. So if we apply this file, Kubernetes know this is a service, so it will create the service for the specific application. So we need to define the kind. Okay, then we need to define the service names. So we are going to create a service, right? So we need to define a service name. So this is a name. And under the spec, we need to define the type. Okay, here you can see the type as load balancer, L capital, B capital. Cluster IP, C capital, I capital, like that, not for N capital, P capital. Otherwise, we will face some failure. Okay, it's not creating anything. And this is the main part. Okay, how the application is connected with the how this service connected with the specific application. So that is we need to define under the selector. Okay, selector parameter, we need to define the application, which application this service for. So you can see Mario. The Mario application we already defined in the deployment file, right? For the application name is Mario. So this is unique, and this is we define under the label in the deployment file. Okay. So using the label, actually, this service is connecting with the specific application. Then the port number and protocol we need to define TCP. The port number is 80. Okay, and the targeted port. This is a container port 18. So here we need to define. So this is fine for a service, and we need to save and exit and apply kubectl. Before that, I will show you one thing. Just to go to the EC2. So coming to EC2 dashboard, we can see the node as well here. Okay, under the instance, we can see that 3 node running. See, these are the nodes for the Kubernetes worker nodes. And this is a node that we are managing the Kubernetes, okay. And coming to the load balancer, okay, see the load balancer, we don't see any load balancer here, right? See, no load balancer here. So in this service file, okay, we define service type as load balancer. So you can see when we are applying the file, it will create a load balancer. I mean, the managed, this is managed Kubernetes, right? So the AWS will automatically go here and now it's visible, right?
Yes.
Yeah, it's created now, okay, whenever I am applying this file. Okay, also we can check the service kubectl get search VC. And here you can see it will create another service, that is Mario service, the name, and the type is load balancer. Also, you can see the external IP, how we accessing the application. So this is the DNS name of the load balancer. So we need to copy this one and paste it in the browser. We can see the application. So this way we will deploy application using Kubernetes. Create a YAML file, and we need to define the service file and everything. This is a game actually, okay. Got it. So anyone have any doubt? All of you?
No,
Can
done.
we? It is a lot more actually. Can you repeat the same class tomorrow to Taufik?
Sorry?
It might help digest the lot of material.
Yeah.
But going forward, we need to deploy a lot of cluster actually for different scenario. For example, some deep topics are there for Kubernetes. So at least we will set up, I mean, 8, 10 cluster within the entire course.
I think it will
Got it.
help if we repeat the class though. I don't know what everybody else thinks, but
Okay, so which scenario you have doubt, all of you? So I will concentrate on that part as well. The deployment or the YAML.
Everything today, whatever you have gone through, I was like, it is a Greek and Latin for me for sure.
Okay.
I think in general overview of like all of these things, if just repeat it might help digest it a little bit. You can have the
Got it.
same class maybe almost.
Okay, then I will briefly go through the similar scenario. Okay, so you will get more idea. Or else you just now you all got the overview, right? How to create a cluster. Oh, okay, one thing I will give one task. Okay, can you do the same lab within your environment? All of you. And if you face any issues or doubt, just write it. Okay, so I will explain that specific topic as well tomorrow.
No, that's what, how we need to, from step 1 to step 2, what we need to do. I'm like, it is not clear for me. Like, I don't know. I think you went fast today. Not sure though, whether it is only for me or for everyone.
I
Okay,
think
then
so
one
too.
thing.
I think maybe just repeat the lecture tomorrow might help, and then we'll do the task that you're saying.
Okay. That's fine. Then I will explain the same tomorrow. Okay.
That would
Thank
be
you so
great,
much.
actually. Yeah.
Sure. No issue. Then we
And
can wind up
also,
today's session.
yeah, and also
Yeah.
we have a lot of lag today. Maybe that might be other reason too.
Lag in the sense of network issue or
Yes, network issue.
okay. I also face some network issue. I mean, in between 3-4 times it's log off and log in my Zoom meeting. Okay, then we can do the same tomorrow. Okay,
Yeah. Thank
with
you.
some more topics as
Thank
well.
you so
Yeah.
much, sir.
Yeah. Bye all.
Have a good
Bye.
night. Good morning. Bye.